In this video, we are going to continue with normal distribution, where normal distribution is one of the continuous probability distribution. A normal distribution is a continuous probability distribution where the density function has a bell-shaped graph. So this is the bell-shaped graph. Okay, and this bell-shaped graph is symmetric around the mean. So meaning that this bell-shaped graph here, at the middle part of this normal is our mean. So this is the value for mean. Okay, and the total area under this curve would be equals to 1. Meaning that since this is a continuous probability distribution, so it involves the integration. Okay, so to find the total area under the curve would be from negative infinity up until infinity. So the total of this would be equals to 1. Meaning that half of this bell graph would be equals to 0.5. And the other is also 0.5. So although the normal distribution has the characteristic of symmetric bell-shaped curve, but the centers, its centers here and dispersion differs. Let's say here our mean is equals to 5, and this standard deviation where the variance, the variance shows the dispersion of the curve. So let's say this one is equals to 1. Okay, and at the same time we have a normal distribution given that the mean is equals to 5, but our variance is equals to 4. So the shape will be different. Okay, since the variance is greater than 1, meaning that the shape of the curve will be like this, where it is more dispersed compared to sigma square equals to 1. But still the shape is still a bell shape. Okay, sorry. So something like this. Okay, where it is more dispersed compared to sigma square equals to 1. And also, if I have another normal distribution, given my normal distribution mu is equals to 10. So the center of this bell shape will not be the same as when the mean is equals to 5. So it will be changing depending on where your mean is. And let's say here is sigma square equals to 2, for example. Okay, so this is normal distribution. So the normal distribution is very important in statistical inference because number one is the measurements obtained in many random process are known to follow normal distribution. Okay, and the second one is this normal probability distribution is actually fits many human characteristics. So if you try to get the height of MG student, for example, and you collect the data, and you will see the shape of the height of the MGIIT students follows this normal distribution, where it will have this bell shape. Or another example is the speed, IQ, and years of life expectancy. Another reason is normal probabilities can often be used to approximate other probability distribution such as binomial and Poisson distribution. So we will learn this in the next chapter. And the last one is distribution of statistics such as the sample mean and the sample proportion are normally distributed when the sample is large, regardless the distribution of the parent population. Okay, so this is why normal distribution is important. So I have give you the example of normal distribution, and I mentioned about mean and only the variance. So meaning that, okay, normal distribution can be described by only these two parameters. Okay, so you need to know a mean and also standard deviation or a variance. Okay, once you know this, okay, then you know the normal distribution. So here, if our x is a normal random variable, given the mean is mu and the standard deviation is sigma, so the density function will be equals to 1 over the square root of this 2 pi sigma square exponential to the power of negative x minus mu square over 2 sigma square. And given, okay, this normal distribution follow n refers to normal distribution, mean and variance sigma square. Okay, so meaning that this random variable is normally distributed with mean mu and variance sigma square. And this is the function or density function of a normal distribution. So let's try this example. Okay, given that the mean number of hours a Malaysian worker spends on the computer is 3.1 hours per workday. So here we have our mean, which is 3.1. Okay, and here we have the standard deviation, which is 0.5 hours. Okay, so you have to find the percentage of workers who spend less than 3.5 hours on the computer. So we need to find our x, which is less than 3.5. Given your x is the number of hours Malaysian workers spends on the computer. So since if I draw the normal distribution, okay, because here we assume that the variable is normally distributed. So our mean here is 3.1 and sigma is equals to, or sigma square would be equals to 0.5 square. So we want to find, okay, x is less than 3.5. So we need to find the area that is less than 3.5. So here is our 3.5. So meaning that we have to find the integration of from negative infinity up to 3.5 and then integrate the function where the density function of the normal is equals to this 1 over square root of 2 pi, okay, and then sigma square and then e to the power of negative x minus mean square over 2 times with sigma square dx. But I don't think we have time to solve this because it's very complex, isn't it? Okay, so this is a very complex function. So it is impossible for us to solve this. So what we can do is, okay, since the function is so complex, so it is time consuming to determine the areas under the curve. So we can use the table of normal probabilities to analyze the normal distribution problem. However, okay, different problem will have different mean. Let's say this one we have mean is equals to 15 and the sigma is equals to 1. And another problem here we have, let's say the mean is equals to 3. Okay, and the variance is equals to 0.1, for example. Okay, so it will be difficult because the table would be different. So we have to know when mu is equals to 3, what will be the table. given that the variance is what? Okay, and then for mean is equals to 3.1, the table would be different. So, okay, to simplify this, what we can do is we can find the standard normal distribution, or we transform this normal distribution to a standard normal distribution. So what is standard normal distribution? So a standard normal distribution is a normal random variable with mean equals to 0. So we define any mean, okay, that we get, we transform it into a standard normal. Okay, given this standard normal is mean equals to 0. And the sigma square is equals to 1. Okay, so this is our standard normal. Okay, mean is 0, the variance is 1. And this problem, we denote it as Z. Okay, capital Z. So this standard normal, we call it as Z. Okay, so the probability density function for a standard normal random variable is given as this 1 over 2 pi exponential to the power of negative z squared over 2. Okay, and the cumulative of a standard normal random variable is this denoted as the probability of z less than equals to z score. Okay, so remember, okay, given we have a normal problem, we have to transform this into a standard normal distribution. Given the standard normal distribution is given as mean equals to 0 and the variance will be 1. So any problem, okay, given that the mean is equals 15, standard deviation is equals to 2, or any problem that comes with mean equals to 2, standard deviation is equals to 0.5. So we don't have to solve it differently. Okay, we just have to convert this into a standard normal. Okay, then we can solve our problem. So how can we use the standard normal random variable? Okay, so a z value restates the original value x in terms of the number of units of the standard deviation by which the original value differs from the mean of the distribution. Okay, so the negative value of z indicates the original value of x is below the value of mean. So here is our mean, which is equals to 0. So the negative of z refers to the negative area, okay, and if it's positive z, okay, so it will be on the right side of the mean. And if the value of x is more than mean, here, okay, so the value of z is positive. So this graph shows the standard normal distribution given this is our mean. Mean is 0. Okay, and here this value shows the z-score. Okay, so the z-score of 1 meaning that, okay, it is a 1 standard deviation from the mean plus 1 standard deviation from the mean. Okay, negative 1 shows that the negative 1 standard deviation from the mean equals to 0. So the mean with the standard deviation of 1, you can see here that it covers almost 15 plus 19 plus 19 plus 15, which is almost 68%. Okay, for the area under the curve with 1 standard deviation. And for the 2 standard deviation, the area of this normal distribution covers around 95% of the curve. and for the third 3 standard deviation, so it covers around 99.7% from the total area under the curve. Okay. Alright, so now how can we standardize the normal random variable? Remember, I showed you just now, given that we have a normal and we have different mean, 15, mean equals to 3, sigma square equals to 1, sigma square equals to 4, for example. And how can we convert this into a standard normal distribution? Given the standard normal always mean equals to 0 and the variance equals to 1. So here is the formula. So the standard normal distribution is equals to x, random variable, minus with mean over sigma. Okay, so you have to remember this. So here z shows the standard normal random variable equals to x is the normal random variable minus mean, where mean is the expected value or mean and sigma is the standard deviation from the variance of x. So a standard normal random variable can be denoted as this. Z follows normal, given mean is 0 and the standard deviation, the variance is equals to 1. So here, to calculate a probability, okay, from the standard normal distribution is given as this. Let's say you need to find the probability of x less than equals to any value. So you have to find the probability. So we have to transform this where x is the normal distribution to a standard normal distribution. So we have to find the z, the standard normal distribution z. So how to transform this? So x minus with mu over sigma less than equals to, so this value is also minus with mu over sigma. So this can be represented as our standard normal distribution, and we will get the value because we know the value for x. So this is our z-score. Okay, so here is a big explanation. So z, capital Z is a standard normal random variable, and z, small z, okay, x minus mu over sigma is the z value obtained by standardizing the normal distribution x. So the probability is obtained by using cumulative function of a standard normal random variable with z equals to x minus mu over sigma. Okay, let's try this example. We want to determine the probability or area for the portions of the normal distribution described. So here we have z less than equals to 0.87. So here, notice here that this example is in z. So meaning that this one refers to the standard normal distribution. So we don't have to transform, okay, from normal to a standard normal distribution because this problem is already in a standard normal distribution. So how to find this area? You don't have to do the integration because we just have to use the table. Okay, please refer to your Luhmann table. Okay, and then go to table E. Okay, in table E, there are 2 pages of table E. So you can see here, on the first page of table E, here is the Z score or Z value. Okay, Z is equals to negative 3.4, and then here on this first column, in the first row here, we have 0.00, 0.01, 0.02, and so on up until 0.09. Okay, and the first column here, it is up until negative 0.0. Okay, and at the bottom of the page, you can see here there is a graph. Okay, there is a figure where this shows, okay, the area, okay, the value of the area. So the value of here refers to the value of this area. Okay, and this Z, okay, refers to the value in the first column and the first row. Okay, for example, okay, we want to find Z, so here is our Z. Okay, we want to find Z equals to negative 3.3. Okay, so our Z here refers to negative 3.3. So just go to the first column and find negative 3.3, and you can see it is here. Okay, negative 3.3, and this column, this row, shows the second decimal point. Okay, but for our case, it's just negative 3.3, meaning that, okay, the area, okay, of this would be 0.0005. Okay, another example, if your Z is equals to negative 3.31, so you just go to negative 3.3, okay, and 0.1 is come from here. Okay, so this is the area for negative 3.31, which is 0.0005. So if you notice on the first row, okay, at the end of this, all the values of Z is all negative, meaning that this value is all on the left side of the mean equals to 0. Okay, the bell shape is on the left only. Okay, now for the second page of the table E, here you can see that Z value is all positive, meaning that the Z is all on the positive side of the axis. Okay, so here Z, and this is the area. So this meaning that the value of Z is less than this Z value. Okay, for example, I want to find the value of Z is 0.12. Okay, so just go to 0.1 and 2 is here. So you can get the value which is 0.5478. Okay, should be more than 0.5 because half of this is 0.5. Okay, so since 0.12 is on the right of 0, so the total area should be more than 0.5. Okay, so that's why you get 0.5478. So to find Z less than equals to 0.87, so you will find in the table 0.87 would be 0.8078. Okay, so if we draw this graph, here is our 0. So Z value is 0.87. So we need to find the area that is less than 0.87. So you can just straight away take the value of this area from the table, okay, where this area is equals to 0.8078. Now, let's try for question C, because question B you can try it where you can just obtain the value from the first page of table A. Okay, now for C, how to find the probability of standard normal between 0.45 and 0. Okay, remember the value in this table refers to the cumulative, okay, from the 0.45. Okay, so here we want, so 0.5 here refers to the value of this from negative infinity up to 0.45, which is equals to 6.736. But we just want to find the area between 0 and 0.5. So we have to remove all this area on the left side, okay, where since it is equals to 0, from 0, meaning that half of this normal graph is equals to 0.5. So it will be, sorry, this one should be 0.6736. Okay, so 0.6736 minus with the area, half of this area, 0.5. So the area here would be only 0.1736. Okay, so the same application for the D. Okay, D is finding the interval between 1.5 up until 2.55. So the area would be on the right side, okay. So this one would be 1.5 for example, and here is 2.55. Okay, so first we have to find the probability of Z less than equals to 2.55. Okay, then minus with the probability of Z less than or equals to 1.5. Okay, then we get this area. Let's try another kind of example. Okay, so determine Z such that Z probability of Z less than Z equals to 0.024. Okay, so this problem, here didn't give you the value of the Z. Okay, Z value, there's no Z value except that you know this is the area of the curve. Okay, remember in the middle of this is always 0. Okay, half of this always 0.5. Half of this is always 0.5. Okay, and then if the Z value is here, so meaning that it will be 0.5 plus this area A. Okay, so here for the first question, the area is 0.024, meaning that it is a very small area where it is less than 0.5, meaning that the area would be somewhere just here. Okay, given that this area is 0.024. So what you need to do is you have to find what is the value of Z. Okay, given the probability of Z less than Z is equals to 0.024. So so this one is doing the reverse. Okay, we do the reverse process. Okay, instead of finding the area, we know the area, but we need to find what is the Z value. Okay, so first find the area 0.024 in this table. Okay, 0.024, so you have to go through one by one. Okay, and you can see here, okay, 0.024, okay, is this one. Okay, where the Z value is negative 2.82. Okay, so the Z value would be negative 2.82. Okay, so that is how we find the Z value given, okay, the area of the curve. Okay, so next, Z less than the Z value. So the area is 0.89. Okay, 0.89 meaning that it is greater than 0.5. Okay, so here we have 0.5 and here is our 0.89. The total of this would be 0.89. Okay, so you need to find in the second page, okay, what is the value for 0.89. So if you refer to the second page of table E, okay, you have to find 0.89. Okay, so here 0.89 is here. Okay, so if we find the smallest difference, okay, the closest to 0.89. So if we compare with these two value, okay, so here is closer because the difference is just 0.0007, okay, compared to this one which is larger. So the Z value for this one would be 1.23. Okay, so next, Z greater than Z. Okay, meaning that it will be on the right side of Z. So Z is greater than Z is equals to 0.25. Okay, so it can be here. Can it be here? Okay, given that Z is greater than Z is equals to 0.25. Okay, here you can see the area is less than 0.5. So this one is impossible, which is wrong lah. Okay, should be, okay, the Z should be less than 0.5. So it will be on this side. Okay, on the right side of 0. Okay, so how to find this? Remember the table that we have. The area covers the value of Z less than Z. Okay, so we know that this area is 0.2425, but the table, the value in the table shows the area on the left side of the Z score. Okay, so to know the value of Z, we just have to find the 1 minus 0.25, which is 0.75. Okay, so this is the area. This is 0.75. So the Z value, so just go through the 0.75 where you will get between these two values. So I will choose 0.07486 because the difference is just 0.0014 compared to this one is 0.0017. Okay, but what about this one? Okay, what is the difference to 0.75? Okay, this one is larger compared to 0.7486. Okay, so I will use this z value, the closest one, which is, so the z value will be 0.67. Okay, so the z value will be 0.67. Okay, and this one, okay, this example is from B. Okay, so the z value is 1.23. Okay, and then for A, so this z value is negative 2.82. Okay, so now you can do, okay, practice on how to find 2D. The value of, let's try another example. So suppose X is a normal distribution, okay, where it follows n 25, 25. Okay, so this 25 refers to the mean, and this 25 refers to the variance. Okay, remember, this is a normal distribution. So every time it's a normal distribution, you have to convert this into the standard normal distribution. So the standard normal distribution is given as normal, mean is always 0, and the variance is always 1. Okay, so how to transform this into the standard normal distribution? Okay, so let's go through the first problem. Okay, A. The probability of normal distribution X less than equals to 37. So we want to transform this into the standard normal. What we can do is, remember the formula for the standard normal distribution is X minus mean over sigma square. Sorry, not sigma square. Okay, should be X minus mean over standard deviation. So now we represent this, or we transform this for X. So just rewrite X as X minus with mean. So our mean is given as 25, and the standard deviation is square root of 25, which is 5. And less than equals to is the same. Okay, now the value of X, small x, is given as 37 minus with mean divided by the standard deviation. Okay, now we have represent this. We know that this is the representation of Z. Okay, standard normal Z. Okay, less than. So now we can find 37 minus 25 divided by 5, which is 2.4. Okay, now we can use the table. Okay, the standard normal table, given that Z is less than equals to 2.4. So our 2.4 is on the right. Okay, and we have to find the area here. So this one will be the value from the table, which is equals to 0.9918. Okay, so this will be the area of this. So meaning that the probability of X less than equals to 7 would be equals to 0.9918. Okay, so later you can try for B. Okay, I'm going to show you for C. Okay, C, probability of X between 26 and 30. So how can we solve this? The same step. Okay, so this is our small x. Okay, so 26 minus with mean divide by the standard deviation less than equals to. So you can, okay, you don't have write, okay, you don't have to write this x minus 25 over 5. Okay, you can also just write this as z. Okay, meaning that this one, you know, you have transformed this or you have solved this. You have gone through this step, kx minus 25 over 5 for this standard normal of z. Okay, but this one 30 you should show lah, right? You have to show. Okay, now we can solve this and you will get 0.2 z and 1. Okay, so if we draw the graph, so it is more than 0, so it will be here, and 1. Okay, so you have to find the value from the table for z less than equals to 1, okay, and then minus with z less than 0.2. So for z less than 1, you will get 0.8413 minus with 0.2, which is 0.5793, which is 0.262. Okay, so if you notice for question D, okay, the symbol is less than. There's no equals to. It doesn't matter because this is a continuous probability distribution. So less than equals to, this equals to doesn't have any meaning. Okay, but the important part is this part, less than or greater than. Alright. So now I hope you know how to use the table, right? So now let's go through the example using the real problem. So at a certain community college, the time that is required by students to complete the math competency examination is normally distributed. Okay, so this shows that this problem is a normal distribution. Okay, so x will follow the mean. Okay, mean is given as 57.6. Mean is 57.6 and the standard deviation is 8. So the unit is the same, so there's no issue on this. Alright, so if I write the distribution, it will be x follows normal distribution. And the mean is 57.6 and the variance will be 8 square. Remember, this one is always variance. Okay, so now we have to find the probability that a student take longer than 1 hour. So meaning that this one, if we convert to minutes, it will be greater than 60 minutes. Okay, so longer than 60 minutes, here we will write it as x greater than 60. Okay, so first what you need to do is you have to transform this into standard normal. Okay, so it will be z greater than 60 minus mean divided by the standard deviation. And you will get your z is greater than 0.3. So I'm not going to show you how to use the table. You can refer to the table and you will get 0.3821. Okay, and then for B, between 56 minutes and 1 hour. So it will be 56 to 1 hour. So you have to transform this to standard normal. So 56 minus mean divided by the standard deviation. Since we have transformed this into standard normal, so we just write it as z. Okay, then 60 minus 57.6 divided by 8. So you will get this as between negative 0.2 and 0.3, which is equals to 0.1972. Okay, so this is the end of the normal distribution. So the next topic will be how to find the normal approximation for binomial and Poisson distribution. Thank you.